Let's resume chapter 5. On the screen, we have the present value of an uneven cash flow stream. And these are a little bit harder to calculate because you have to make each calculation by itself and then add them all together. So, obviously at time 0, we don't have to do any discounting. There is not a dollar amount here for time 0, but for time 1, we take $100 discounted at 1 year at 4%. In 2 years, we take $300 and discount it 2 years at 4%, and so on. Keeping in mind this last one happens to be negative, so you got to watch the signs on that. Add those all up, and the present value of that's $597.48. So they're just a bit more complicated because with an annuity, with the dollar amounts always being the same, that's an easier calculation than these, which is a series of individual calculations that you have to add up. So that just kind of walks us through the process of how to do that. You can use what they call the CFLO button on your financial calculator if you want to. Like I said, I like Excel a lot, and you can do this in Excel without too much difficulty. And I'll show you guys some things about how to do that. And then they're kind of ask us a few what-if questions or kind of think through questions here. You'll definitely get some of those types of questions in your homework for Chapter 5. It says here, will the future value of a lump sum be larger or smaller if compounded more often, holding the stated I constant, the interest rate constant? And it will be larger. So if we're going forward, let's imagine it's an investment. And we go to the Mr. Banker, and Mr. Banker says, I've got this investment that will compound annually, or I've got this investment that will compound semi-annually or monthly or quarterly or whatever it would be. The more frequently the compounding, the higher the value of the investment. So this one says annually, once per year in 3 years at 4%. This one says semi-annually. So notice with semi-annually, that means twice per year, every 6 months. Okay. And so what changes here, this is annually, so we compound 3 times at 10% annually. If I convert that to semi-annually, twice per year, I have to take that annual rate of 10% and divide it by 2. So that's why you see 5% here. It's just because we're compounding twice per year. So I take 10 divided by 2. But if I compound at 5% every 6 months, that's 6 compounding periods. That's 112.62 versus 10% annually, which is 3 compoundings, which is 112.49. So the 112.62 is obviously higher. No, at $100, it's not significantly different, but if that was $1,000 or $10,000 or $1 million, now we're talking some significant differences. Okay, so interest rates have classifications, what they call the nominal rate and what they call the periodic rate. So I always like to think of when you're driving around town and you see a billboard for a bank, and a bank might have an auto loan rate. Maybe they'll say like 5%, just to give you a nice easy round number. And there'll be a little asterisk by that 5%. There's going to be fine print on the billboard, which is impossible to read if you're driving, right? You definitely don't try to read that. Or if the bank is advertising a certificate of deposit, they're saying if, we have a CD for 3%, and of course it'll have a little star there and a whole bunch of fine print about, all the little details you have to meet to earn that 3%. Well, they're quoting in that big rate they're showing on the billboard is the nominal rate. Okay, either it's also called the quoted or stated rate. Okay, and it's the annual rate that ignores compounding effects. Okay, but the periodic rate now takes into account compounding. So the question for that CD would be, how often is the bank compounding for me? That would be the big question I'd want answered. Okay, so the periodic rate then reflects the compounding. Same thing with a car loan. Let's just say a bank offers a 5% car loan. That's going to be based on the nominal rate, which is annual. However, Mr. Banker is going to say, here's the loan, and you must pay us every month, right? So that annual 5% becomes some other amount when you factor in the compounding of 12 times per year. So the periodic rate is the nominal rate divided by M, where M represents the compounding. So, semi-annual would be 2, quarterly would be 4, monthly would be 12, and so on. Okay, so it kind of just showing us that and how that turns out. So a 4% annual turns into a, if it's semi-annual, turns into 4.04%. If that, that nominal rate turns into the effective rate, it'd be 4.04. Okay, so of course, why does that matter? Well, it matters because compounding intervals determine what the returns are. So it's just a matter of being educated both as an investor and a borrower of what exactly is the fine print, right? How often will the compounding be happening as a borrower or as a saver? So this kind of walks you through 4%. And it shows you, I like this slide because it kind of shows you what the typical compounding periods are: annual, semi-annual, quarterly, monthly, and even daily. And you that might think the daily one is going to be this really crazy amount. It's really not that much more than monthly or quarterly. It's obviously higher, but not significantly higher. Okay, so just kind of be aware of that. One is each rate used. The nominal rate is kind of what banks show you when they're trying to advertise and so on, but all financial institutions have a lot of regulations they have to follow and disclosures when it comes to advertising rates. And so when you do finally go to the bank and talk to them about the rates, they have to walk you through a whole bunch of disclosures, and you sign off to say, I recognize that the annual rate was 4, but the effective rate's 4.07 or whatever it is. So they'll walk you through the fine print. So they kind of just see that nominal rate up on the billboard to get the hook, but then they'll explain all the details to you later on. Okay, and this kind of just shows us a little bit about how that changes the answer. So just the different compoundings. Okay, so I'm going to skip a few things here, and then this one here shows us the semi-annual interest rate to kind of taking a 3-year $100 annuity, and we're going to compound now semi-annually, and how does that kind of change the answer, right? And we'll get into this deeper in chapter 7 is the bond chapter. We'll kind of talk about this stuff a little bit closer then, but this gives a good example of when you begin to compound semi-annually, that 4% annual rate becomes a 2% semi-annual rate, right? So that's what's different about it. That just walks us through what the calculation ends up to be then. That's on the timeline approach, and this is just using your financial calculator to get there. Okay, so I'm just going to kind of wing through those because we're going to cover that kind of stuff a lot closer in the next chapter. Then loan amortization, just an example of when you go and borrow money to buy a car, you get a home mortgage or whatever that would be. The bank may give you a table. They might print that out and give it to you or show it to you that says, your monthly payment's going to be, let's just say, $500 throughout the life of the loan. However, as you make each payment, the amount of that $500, the difference between what goes to principal and what goes to interest, changes every month, right? And if you've ever seen an amortization table, they start out in the early years of payments, it's more interest than principal. In the later years of the payments, it flips towards more principal than interest. It's a very common way that works out. So they're kind of showing us here, if we're going to borrow some money, $1,000, interest rate is 4%, 3 years, what the payment would be, then to basically make 3 payments and take care of that loan. Okay. And then just finding interest paid in the year. Very simple interest. This is an example of simple interest where it's compounded annually. $1,000 principal times the 4% would be $40. Okay, and so the difference then is it says here if a payment of $360, $35 was made at the end of the year, and $40 was paid toward interest. The rest of it's principal. Okay, so the principal is the payment minus the interest. And then the balance of the loan then is the principal balance of $1,000 that was borrowed minus the principal repaid of $320. So that after 1 year, the principal left is $679.65, and then this is an amortization table right here. Just a very simple, easy 3-year one. So no matter what, we make a $360 payment, and then what goes to interest versus what goes to principal changes every year. But at the end of the third payment, the loan's paid off. This kind of just shows us how that works out. So the principal payments go up, the interest payments go down. Okay, and so that was chapter 5 in terms of the slides. Now I want to show you an Excel file. So I'm going to go back and show you where this came from. Let me go to right here. This is just our class in the resources tab. And this is where I have all the PowerPoints, the syllabus, the answers to the questions from the back of the chapters. All that good stuff is here. Then under chapter 5, so unit 4, chapter 5, is this file right here. And I've got an example of an amortization table right here if you want to take a look at one. Almost every chapter has some kind of an Excel file that the author has provided. You can definitely look at those and just follow that along as examples, because that's what's in your chapter is screenshots of those Excel files. But this one right here called BOS 305 FV and PV calculations, this is one that I put together to kind of help you do the homework for the chapter. And I want to show you, I'll start out by going to this section right here where it says computing effective annual rate. Let's go back to that 4%. Okay, so this formula down here is called the effect formula. And so we take the nominal rate, the 4% annual rate, and then as I change the number of periods, the effective interest changes. So 4% at twice per year is 4.04. Quarterly, 4 times per year is 4.06. Monthly is 4.07. And daily is 4.08. So that was just like a slide that I showed you how to do that with, which is this one right here. Okay. And then I wanted just to show you, I'm going to go back to some of the first examples they gave us of doing some computation. So let's do this one right here. We'll do the future value of $100 at 3 years at 4%. So up here it says future value of an amount. So it's $100. The interest rate was 4% at 3 years, and we get $112.49. So the Excel file is just right here, the rate, number of periods, the payment, which is 0, and then the number of periods. And so if I just hit those, I get the answer of 112.49. Hopefully everybody kind of see how I did that. So the same thing you see here is the same thing you see here in this formula. Okay, so it might be good practice if you just take some of the examples from the PowerPoint and you just plug those into my Excel file to see if you can replicate the answers. So this is the same thing now, but just on the present value side. So let's do the same thing for present value. So this is present value of an amount. The future value is 100. The interest rate was 4. It's still at 3 years, 3N, and I get 88.90. And so here's my present value formula, all the various inputs. So these formulas are almost the same, these two. They're very close. Okay, you just got to really be careful which one you're taking a look at. So I get 88.90, which is my answer. And then here's the one that's solving for the interest rate. So it says basically what interest rate will turn $100 into $119.10 in 3 years. Okay, so it's called the rate formula. And we'll go down to the bottom is where I've got this one. So the future value is $119.10. The present value was 100, and we knew it was over 6 years. Oops, my bad, 3 years. We get 6% as the answer. Okay, so here is the rate formula. You can see all that. Now with this one, you have to really be careful. With anything in this bottom row, you have to really be careful about the future value, present value, and the signs. If you enter them both the same sign, you're going to get this. It'll be pound num. And it just means the math doesn't work. It can't recognize it. So as long as one is negative and one is positive, it doesn't matter which one's negative and which one's positive. It will work out. Okay, so if you get that pound num, just watch the signs of your inputs. Okay, so I got that 6%. Now I can do the solve for n, same thing. We'll do the doubling at 10%. We're going to solve for the number of years if something doubles at a growth rate of 10%. So here's solving for n, the NPER formula right there. And again, I have to kind of watch the signs. So let's just say I've got $1 today. I want to grow that and double it, and I want to do that at the growth rate of 10%. I get 7.27. That's exactly this rounded to 7.3. And again, it could be any two numbers. It could be 2, it could be 4. I get the same answer. But again, you also have to really watch the signs. If they're both the same sign, it does not work. One has to be negative, one has to be positive for that to work out. Okay, so there's that one. And then let's do some of the annuity ones too here. So here's my ordinary annuity, future values. So this is 3 years, 3N, interest rate of 4, and the payment is $100. So future value of an ordinary annuity. So I go up to here, I find where it says future value of ordinary annuity. Payment's $100. Interest rate was 4, and it's over 3 years. So here's my formula. It's the FV, and it has all the various inputs. And where that 0 is, right here where my cursor is, that's the type. And that 0 in the formula means this is an ordinary annuity. Okay, so 3, 12, 16, and that was the answer they gave us right here. Okay, and do the same thing on the present value side. So let's take the same amounts and bring them down to present value. So present value of an ordinary annuity is right here. So $100 payment, 4%, 3 years, and again it's ordinary because the 0 is right there. So I get the same answer, 277.51, that I had right here. And now we'll get to the annuity due. So let's go back to future value of the annuity due. And this one's right here, future value of an annuity due. And this is, again, just the only thing I have to change is the 4%. Go to the formula, and there's a 1 right here. And that 1 is the type, and that makes this be the annuity due. So $100, 4%, 3 years is $324.65. And so what I want everybody to see is that I've got the exact same inputs here and here, and the annuity due is a larger amount. And that will always be the case when we have the exact same inputs, because I get that money sooner at the beginning of the year, so I've got more compounding. So the annuity due always has a higher value. Okay, so I got that 324.65. And the same thing on the present value side. Let's do the present value of the annuity due. And we'll go back to here. And that's right here, present value annuity due, $100, 4%, 3 years. I get the 288.61, which is my answer right here. And again, on the present value side, it works out the same way. It's a larger amount. Okay, so I just showed you every single one of these formulas. My suggestion is you use this template here. This should help you answer the vast majority of the number crunching questions that you will see in Chapter 5. So my suggestion is dive into this for Chapter 5 and you'll be in really good shape. Okay. As always, if you have questions, just let me know. It can be a little tricky trying to figure this stuff out. I totally understand that. And again, I think Excel is the way to go. That's just what I always kind of got used to doing when I was more in the corporate world. But there's lots of ways to do present value, future value. If you're more comfortable using a financial calculator, that's okay too. It doesn't matter to me how you get there. If you prefer a calculator, I would just say try both. Do a calculation in Excel and then see if you can't replicate the calculation using a financial calculator. Okay, we'll go from there. Thanks.